Hello, I am Gaurav and welcome to my channel Code with GT. In this video, we will see how to design a web crawler. A web crawler is a classic and interesting system design problem. First, let's understand what a web crawler is. A web crawler is something that crawls through the website. So for example, you can have a web crawler. Suppose this is my crawler and we give it a website, let's say gd.com. Now this website will be an HTML document, a website that we see on the browser, and this page may be about something related to technology, and this may be referencing other websites. For example, this technology website explains something about AI and then has a link to an AI website. Let's call it URL1, and subsequently it makes use of many different URLs, URL2, URL3. So we say that gd.com is referencing URLs URL1, URL2, URL3. Now when this web crawler crawls this website, it goes through these URLs and it opens all of these URLs, and this URL1 may be further referencing other URLs, say URL A. So this web crawler will keep on crawling all the websites it references. So this is the basic concept of web crawler. Since this web crawler is crawling websites like a spider, so it goes to one point, then it goes to the reference URLs and so on. So these are also called as spiders, and in some places it is also referred to as a robot because it is automatically crawling through different sites. Now that we know what a web crawler is, let's gather the requirements and start designing it. This video is part of my system design playlist where I will be discussing high-level designs of some of the most classic system design problems. So don't forget to subscribe to my channel and share this with your friends. So first we need to know the scale of operation. This will help us in determining two things. One is storage, like how much data we need to store, and the second is we also need to know how much CPU will be required, like computation. Scale of operation is important. Let's assume our web crawler will crawl through 1 billion pages in a month, and we are interested to store data of the last 5 years. Talking about storage, this means in 1 year I will have 12 billion pages data multiplied by 5 years, which will give me 60 billion pages I need to store. Now assume that each page that I crawl has a size of 500 kilobytes, since most of these are only text. So this into 500 kilobytes will give me 30 petabytes. So my storage should have at least 30 petabytes of storage available for this to happen. Next, let's come to computation. So my crawler is crawling through 1 billion pages per month, which is equal to 1 billion by 30 days. Now going at the hour level, 24 hours into 60 minutes into 60 seconds, which is equal to 400 pages per second. So this is the rate at which my crawler should work, like it should crawl through 400 pages per second. Now we also need to know what type of content my web crawler wants to crawl through. For example, a website can have text or images or videos, or then there can be other forms of metadata as well, like audio and so on. So the first important thing to know is what is the purpose of this web crawler. Like, web crawler is crawling through web pages, but why is it crawling through web pages? So my use case for this is I want a web crawler to index websites. Google.com, a very popular search engine, it uses a web crawler. Its name is Googlebot, to crawl through websites and index pages, so that when you search for any search term, if Googlebot has already seen that web page, it will index it and show in its search results. So that is one of the use cases of indexing websites. So now that we know most of the basic requirements, let's start designing it. So my web crawler needs a starting point, the URL through which it wants to start crawling the web. For web crawling, we are assuming that all the websites will be interconnected, like all the websites will be linked to some other website. So I will not use one starting URL, I will use a set of URLs. I will call it seed URLs because I am seeding my web crawler with these URLs. So the question is, how do you select seed URLs? You can have several strategies to do it. So my goal is to cover as many websites as possible. So one strategy is I give it URLs country wise. So for India, I have a set of famous URLs, web pages, which I feed. Then for USA, I have a set of URLs, and for Australia, I have a set of URLs, and these go in as the seed URLs. The second is we divide the URL space into different categories. For example, I have a set of URLs for technology, and a category can be cooking, which is a very famous category. The third is maybe healthcare and sports. So broadly, these categories can cover the entire URL space. So I'm good to go with these as my seed URLs. Now each category will have several URLs. After I have feeded my system with the seed URLs, the second box will be something I will call URL frontier. The goal of this URL frontier will be to decide which URLs I want to download. For example, if there's a URL which we have already visited, we don't want to download it again. We will see about URL frontier in more detail at a later timestamp. And after URL frontier, I need to go to HTML downloader. This component will simply download the web pages from the internet. Now this will internally use some sort of DNS resolver. So once the web page is downloaded, we want a service that will look at the content of the web page and parse it for indexing. So I will call it content parser. This content parser needs to be a different service because parsing the content is a time taking process, and it will also have some algorithms or hashes by which it wants to index the web pages. Also, content parser will filter out garbage data or site that may have malwares and stuff. So content parser will work at a slower speed than the URL frontier or HTML downloader, the part that will actually crawl the websites. So this is a separate service, and it can probably get the list of downloaded web pages inside a queue that it maintains. So HTML downloader can put the content in this queue, and the content parser can keep on reading from the queue. That way this content parser is not overloaded with data. Now next part is content seen. We need to determine if the content that the content parser passed is actually visited before. So as per statistics, around 30% of data on the internet is duplicated. So you will have around 30% of websites that have duplicate data. So we need to filter out such content because it will also help in saving space. We don't want the same content to be stored multiple times. One of the ways to detect duplicate data is if we are dealing with text data, we can like compare character by characters. But one better way is to hash the data and compare the hashes. I won't go into more detail of this, but like that is the overall idea. After content seen, the next block is storage, where we want to store this content. Now storage can happen in memory, that is RAM, or we can also store in the hard disk or the SSD, the system storage. One good strategy is the websites that are like, since we are using it for indexing, the popular searches can be stored in memory so that retrieval is faster, but we can't store everything in memory, so the less frequently retrieved data can live in the storage. The next box is URL extractor. Once the content is parsed, that content will also refer to certain URLs. For example, we had a website a.com. The HTML of this can reference maybe b.com or c.com. The purpose of this URL extractor is to extract all those URLs. This can return a list of the URLs, and after this, the list of URLs can go into something called URL filter. Now, this URL filter can filter malicious URLs or the type of URLs we don't require. For example, we don't want to index video data or audio data, so it can use the extensions to remove those URLs. Or if there are any blacklisted websites, the URL filter will filter that list of URLs, and then it will send it to another module which I call URL scene. Now this works similar to how content scene works, but it works on URLs. So for example, if there's a duplicate URL, this URL scene will filter it. Like we don't want that URL to be indexed again or crawled again. Now this can make use of hashes, hash map to check if the URL is already visited, or there is also something called Bloom filter, which is a probabilistic map sort of thing. You can use that as well to see if the URL has been visited. And now for the URLs that are not seen, it will feed those URLs in the URL frontier and the loop will again start. So this is the basic overview of how my web crawler would look like. Now let's deep dive into some of the basic algorithms and components of this entire workflow. So the first interesting question is whether I should use a DFS based approach, that stands for depth first search, or I should use a BFS approach to crawl through websites. So BFS stands for breadth first search. So you would be thinking these are concepts of graph. Why am I bringing it up here? So if you look closely, the web crawling is also similar to how a graph works. So if you have a.com and it can reference multiple websites, b.com or c.com or even d.com, and d.com can reference three websites, let's say e.com, f and g. Now e.com can also reference back a.com and it can have h. So if you'll see, this is a graph actually. So now there are two ways to crawl. One is depth first search. So in depth first search, assume the seed URL is A and it will like first go to a node, let's say C, and visit C. Then it can go to D and then see the children of D and then visit E. So it will visit the websites depth wise. Now you can see the problem here. So for example, if the depth of any particular node is very deep, it will take a lot of time to go to the other child of A, and the processing of one URL will take a lot of time. So depth first search is not ideal in this case. We can go with breadth first search. So first visit a seed URL, check all the children of this node, and then apply BFS on these individual children. So we will choose BFS for crawling my sites. The next component we want to deep dive is URL frontier. As you can see from this design, URL frontier is responsible to send URLs for downloading HTML, and in that order the URLs will be processed. So in a way, URL frontier is responsible for the order in which the web crawler will crawl through the website. Now two different factors come into play here. One is politeness, the other is priority. Politeness indicates we don't want to aggressively crawl the websites of a particular domain. For example, we have a site, maybe apple.com, and it can have many web pages. Most likely a website of apple.com will link to another website of apple.com. Let's say apple.com/b or apple.com/c or, or apple.com/d, and these websites would further reference websites of apple.com. Now if your web crawler keeps on calling websites of apple.com aggressively, like it makes close to 100 requests in 1 minute, apple.com may end up banning your IP from ever visiting again. It is also considered a cyber attack called DOS, which is called denial of service. So if you hit too many pings to a server, the server will crash. It won't be able to handle requests from genuine users. So it is considered impolite or borderline cyber attack if you give too many pings to a server. So I don't want my system to send too many pings or crawl too many websites of a particular domain at the same time. So I need some kind of check to prevent this. Now one way to solve this problem is for each server or for each host, for example for apple.com, I can have a queue. So all the web pages, the URL frontier can maintain an internal queue. Let's say this is the queue for apple.com. Similarly, there can be a queue for, let's say, Wikipedia. This is Apple, and there can be n number of such queues. And there will be like something called queue selector. Now, whenever URL frontier gets a website of apple.com, it will put that in this queue, and these can be FIFO queues. Similarly, there's a website of Wikipedia, URL Frontier puts it in Wikipedia queue, and my queue selector service, it it maintains an internal system where it knows which queue. uh, Now this queue selector has, let's say, multiple worker threads. It has exactly one thread for each queue. So for example, apple.com will have a worker thread. We call it T1. Wikipedia will have a worker thread T2, and so on. Now the function of this queue selector is to pick up data from Apple queue and push the task to T1. Now the T1 worker thread can have delay added between two subsequent downloads so that it won't overwhelm the Apple server or the Wikipedia server. This is how we can manage politeness while crawling through web pages. The second is priority. So by priority, I mean certain web pages can be more important than other web pages. For example, apple.com, the homepage of it is more important than some random community discussion for maybe some issue. We need to prioritize main web pages first rather than these small unimportant web pages. So all web pages on the internet have something called page rank. It determines the importance of a page, like how many people actually visited the page, found it useful. So page rank is something that is available on the internet. So URL Frontier can make use of that information and have priority queues. So it can have, let's say, P1 and P2 and so on till PK, where P1 is of a higher priority than P2 and so on. And we can have a service here called prioritizer. Now this prioritizer knows each queue and knows the priority of each queue. So when a website URL comes in, it checks the priority and accordingly puts the URL in one of these buckets. So each bucket can have a range. For example, P1 can have a range of page rank between 100 to 90. P2 can have a page range of 90 to 80 and so on. And this prioritizer can randomly pick up websites from it in a weighted fashion. So each queue can have a certain weight, like probabilistic weight. For example, it can say that 50% of times I want websites from this, and with maybe 30 probability I want websites from this queue. So this way the prioritizer can work. So the final design can look something like this. An input URL comes to the URL frontier. We check the page rank and put it into priority queues. We have a prioritizer which in a weighted fashion or in a probabilistic fashion picks up important URLs with a higher probability and passes it on to the politeness component. Now in politeness component, based on the domain or host, it is put into multiple queues, and we have a queue selector that maps these URLs and pushes it to a worker thread. And inside the worker thread, each URL is processed with some delay. It is passed on with some delay. So this is a deep dive into how the URL frontier component would work. Next component is HTML downloader and this DNS resolver, how these components would work. Now DNS resolver can live in a cache which is stored in memory, because for each URL we don't want to go and find out the IP of that. So we can have a local cache in which DNS mapping is present. This is a standard way of doing it in even our local machines, but just pointing that out. Now coming to HTML downloader, how will this actually work? The DNS resolver is out of the picture as we will be using cache. The second is each website has something called robots.txt. Now this robots.txt has information on which paths the crawlbot is allowed to crawl. So for example, robots.txt can have a disallow list of paths that the crawler is not supposed to crawl. It can be an internal page, a page behind the paywall, or a page that the content owner doesn't want to be crawled or indexed. So HTML downloader needs to first read robots.txt for that particular host. It is present at the host level, and then see which URLs it can't crawl or which doesn't need to be indexed. Now downloading robots.txt before each visit is like something that can be optimized. So for each host, robots.txt can be stored in the local cache, and it can be updated with a certain frequency or re-downloaded with a certain frequency. So this is about robots.txt file. Now in the diagram, we had something called URL frontier, and then we had HTML downloader. But HTML downloader is a slightly time-taking process. So after URL frontier, we can have multiple versions of HTML downloader. So this can be a gateway which distributes the URLs or partitions the URL space into multiple HTML downloaders. So this way we can improve performance optimization. So this can be one box. We can have a second, third and fourth box and so on. Also, one more optimization can be we distribute these servers geographically. For example, if I have a set of URLs which are hosted in, let's say, India, one distributed system can be located in a region close to India, which will take URLs that are specifically from that Asian region. Similarly, one set of distributed system can be in USA for servers that are hosted in US. Since the servers are geographically closer, the operation will be very fast as website fetching time will reduce. So I will write that point here. So one is many worker threads. The second is geographically closer servers. The third point which we need to keep into consideration is add some sort of timeout. Timeout because assume the downloader is trying to download a web page but the server doesn't respond. In that case, if we have a timeout, the downloader can move on from that URL and start processing the other URL in the queue. Now, since the URLs are divided into HTML downloaders, we can use some sort of consistent hashing so that it is easier to manage the number of HTML downloaders. It is easier to add or remove downloaders, so we have consistent hashing. Now, in general, we need to take care of certain things, that we have proper exception handling in place and exception logging. These are like beneficial for a good large scale distributed systems. So exception logging can help us identify bugs and solve it sooner. Then the data of the web pages may have some noise, so we need to remove data noise as well. For example, we don't need to index advertisements or things like that. This is also something that needs to be taken care of. And as I mentioned, nearly 30% of the content on the internet is duplicated. We don't want to reindex duplicated content because it doesn't add anything. So take care of redundant data. The fourth is something called as spider traps. For example, in some websites, for example, you have a.com and /a will be a website, then /b will be another website, and /a will again redirect to this website, but it will still exist. And this loop can go till infinite times. This will end up using a lot of computation power and something which you don't want. So you can set a max limit on the length of the URL which you want to process. So these were some of the bonus points which I wanted to share. And that's it for this video. If you like this video, don't forget to subscribe to my channel Code with GD. See you in my next video. Till then, happy coding. Bye bye.